Hello friends, welcome to my channel Study Corner. In last video we discussed on the laws of the motion, why motion happens, about the forces like gravitational force, normal reaction force, and the last one is a tension force. It would be great idea to watch that video and come back over here. Now let's back to the topic. So between 384 to 322 BC, the Greek thinker Aristotle given some idea based on the motion, but he proven wrong between 1564 to 1642 by the scientist Galileo Galilei. After that, between 1643 to 1727, Sir Isaac Newton came to the picture and modified the ideas of the Galileo Galilei. Here we only discuss on the Aristotle's fallacy and Galileo's experiment. Aristotle's fallacy. The Greek thinker Aristotle 384 BC to 322 BC. The Greek thinker Aristotle held the view that if a body is moving, something external is required to keep it moving. According to him and according to his observation, he concluded that an external force is required to keep a body in motion. According to his view, for example, an arrow shot from a bow keeps flying since the air behind the arrow keeps pushing it. Something like air. So, most of the Aristotle ideas on the motion are now known to be wrong and need not concern us. Here, let car is at a rest. Let car is at a rest. Consider this position as a natural position. He believed that every object in the universe has its natural position. So, if we take a ball, then it has its natural position. If we take a bus, then it has its natural position. So, he think every object in the universe has its natural position. Suppose the child with the robe. Here, the child with the robe, which is tied with the car. Now child is trying to push the car in this direction. Then what will happen? The answer is car will moving in this direction. So now if child gone somewhere by leaving this robe, then car will come to the rest. So conclusion is object keeps moving till the force is acting upon it. If it is removed, then it will come to its natural position. Remember the word object keeps moving till the force is acting upon it. If it is removed, it will come to its natural position. Now let's see what is the flaw in Aristotle's argument. The answer is a moving toy car can come to rest position because the external force of the friction on the car by the floor oppose its motion. To counter this force, the child has to apply an external force on the car in the direction of the motion. When the car is in uniform motion, there is no net external force acting on it. If the car is in uniform motion, then there is no net external force acting on it. Simply, if car is in uniform motion, there is no net external force acting on it. Now, the force by the child cancels the force, and this force, which is friction force, by the floor. Corollary is if there were no friction, the child would not be required to apply any forces to keep the toy car in uniform motion. See, The opposition forces such as friction and viscous forces. The friction force is for solid and viscous force for liquids are always present in the natural world. That explains why forces by the external agencies are necessary to overcome the frictional forces to keep the bodies in the uniform motion. Now we understand where the Aristotle went wrong. He coded this practical experience in the form of a basic argument. So the Aristotle went wrong here. Now Galileo come to the picture. Galileo Galilei. Galileo studied the motion of the object on an inclined plane. So here he considered an inclined plane, ball is moving the downward inclined plane. Here the ball is accelerated. In second case, he considered another inclined plane where the ball is moving up an inclined plane. Here the ball will decelerated. In this case, the motion in this case is retarded. Now he took a third example. In horizontal surface, he observed that there is no acceleration and deceleration in the motion of the ball. That is, ball is in uniform motion. That is, ball in uniform motion. The Galileo concluded that an object moving on the frictionless horizontal plane must neither have acceleration nor retardation. I repeat, Galileo concluded that an object moving on an frictionless, the term important is frictionless horizontal plane, must neither have acceleration or nor retardation. Another experiment by Galileo leading to the same conclusion involves a double inclined plane. Here, a ball released from rest on one of the plane rolls down and climb up the other. If the plane are smooth, the final height of the ball is nearly the same as the initial height. Here a little less but never greater. Remember, it is little less but never greater. In the ideal situation, when the friction is absent, the final height of the ball is same as the initial height. Let's see in the figure. Here in the first case, the final height and initial height, here the final height and initial height is nearly equal to same in the spatial case. In the ideal situation, here clearly mentioned in the ideal situation, which means the friction is absent. In second case, let's see, if the slope of the second plane is decreased, here as we can see in the figure, the slope is decreased and the experiment is repeated, then the ball will still reaches the same height, but in doing so it will travel a longer distance. It is obvious that if the slope is decreased, then ball is traveling longer distance. Now in the third case, when the slope of the second plane is 0, then the ball travels an infinite distance. The slope is 0 means horizontal surface. In other words, its motion never ceases. This is of course an ideal situation. Let's understand. The ball does come to a stop after moving a finite distance on the horizontal plane because of the opposing force of the friction, which can never be totally eliminated. However, if there were no friction, suppose there is no friction, then the ball would continue to move with a constant velocity on the horizontal plane. But there is a friction, so the ball stops. Now, if the net external force is 0, suppose the net external force is 0, a body at rest continues to remains at a rest and a body in motion continues to move with a uniform velocity. This property of a body is called inertia. So definition of the inertia is, if a body at a rest continues to remains at a rest and a body in motion continues to move with a uniform velocity. This property of the body is called inertia. Inertia means the resistance to change. Inertia means the resistance to change. Thank you for watching. In next video, we will discuss on the Newton's law of motion, which is Newton's first law of motion, Newton's second law of motion and Newton's third law of motion.